Very good afternoon everyone. So, we are here again today for the session, and today's session is on the drying technology. As till now we have covered a lot of about non-thermal processing and innovative technologies. So, today we will start with the drying. So, the title for the today's presentation is Superheated Steam Drying, which is a very innovative drying technology and its role in food preservation and safety. The content for the presentation includes the background about the technology, then why we need to produce or preserve the food, food preservation methods, what are the different ways, and thermal drying, why we need to focus on the drying technology, what is the need, why are the losses happening, how we can reduce these losses provided by improving through the food security, with emphasis majorly on superheated steam drying technology, followed by the different classification of the superheated steam drying technology, and with more emphasis at the low pressure drying technology, followed by the why need to select different types of the dryers, what are there and why we need to focus on this one, followed by the final concluding remarks about the technology. Talking about the background of the technology, from the picture if we see over here, we can see the drought conditions, rebellion among the people, political instability can lead to the food prices high. And what could be the causes for these things? It includes, if we can see right now the population is 7.2 billion and is predicted to project to increase from up to 9.6 billion to 12.3 billion. If the population is increasing, definitely it is going to increase the demand from the people for consuming food. Moreover, because of the affluence among the people and different factors leads to shifting to animal product based food diets. And these types to prepare this food, it needs more resources to produce, which worsening the global food security situation. So, and these things apart from that, climate changes that are happening, water crisis, soil pollution, degradation, competition for agricultural land and the land for urbanization are in very competition, because we need to provide not only food, but to shelter also to the people. So, these changes or these leads to that we need to look up for the solution that can be there to ensure food security. Why we need to go for preservation, how the food security can be achieved through the food preservation. Like we know that we have food, so among the food different changes can happen. For an example, physical changes, it all depends upon the temperature, humidity and how we store the food. Like then during transportation, how we are carrying out our material. Different biological changes happen. For an example, fruits and vegetables, they have very good amount of the moisture in them. Because of the presence of the moisture in them, it can easily be spoiled by bacteria, yeast, mold that can easily grow over them. Again, if we do not store them properly, insects, birds and rodents can also spoil the food. So, apart from these physical and biological factor, there are several chemical or biological changes or biochemical factors are there that can lead to the spoilage. For an example, non-enzymatic browning or changes or enzymatic changes, non-microbial aspects which leads to the oxidation processes, eventually leading to the rancidity of the food. If we can see, the 25% of the world food supply is lost due to spoilage, majorly during the supply chain. If we are not maintaining properly supply of the chain supply or temperature condition or humidity conditions, and other than that microbial spoilage can also occur. Now, how we can reduce these one? We can reduce this infestation of the food from microbes, insect or other vermin. We can prevent these microbial growth. We can reduce these deteriorative reactions and maintaining the nutritional properties by the different food processing technology. So, that is why food processing is very important in aspect in order to preserve or save the food and to reduce the losses. Now, there are several preservation methods, like the very first one is the physical method. Among the physical method, the very first one is by removal of heat, which is very common and can be seen at every household also, where by the refrigeration system we remove the heat and store the food at lower temperature. Another is by addition of heat. Examples are heat processed product, like canned products are there and different method of the processings are there. The very popular from the old times is removal of the moisture. So, what it could be? It is the drying process. Through the drying process, we can remove the moisture from the sample and can have a longer shelf life of the food. The second aspect is the chemical. These are the old also. The chemicals can be natural or it can be the synthetic, but the natural methods are there. For example, addition of salt. Can you tell some example? For example, for the salt is the pickle. Pickle preparation with along with some oil can have a longer shelf life of the vegetables. Addition of the sugar, so many murabbas and products are there where we add sugar and have an extended shelf life, and which can limit the growth of the microorganism. Addition of some acids or preservatives like benzoic acid, citric acid, there are several ways based upon the pH, based upon the microbial growth, depending upon the type of the product. We add these additives into this one in order to preserve the food. So, after physical method, chemical method, the third method is biological method. Among the biological method, the fermentation is a very old process method and have been adopted for the preservation of many food commodities. The fermentation, the very best part about it is that it produces so much good flavor compounds and break down the higher molecular compound into the smaller one to enhance the flavor along with the shelf life. Among the other non-thermal method or hurdle approach are like non-thermal processing, HPP, that you have covered in the previous section, pulse electric field and cold plasma. These are the several non-thermal method also that maintains the nutritional aspect along with the decontamination of the food products. As we know, in the human history, the drying has been practiced from a very long time, and like very simple examples, whether it was fruits, whether it was vegetable, whether it was grains or meat or any kind of the product. We used to hang it over in front of the sunlight so that the moisture can be evaporated and the water activity could be lowered down so that they can be consumed over a long period of the time. Talking about the thermal drying, what exactly is the thermal drying? It is basically, you can say, a unit operation which involves removal of the moisture content. Moisture is very important over here. Why? How the moisture is getting removed here? Because of the vapor pressure differences. And how this vapor pressure difference is occurring? It is because of the application of the heat. That is what we say as a thermal drying. Okay. Then you might have heard that drying and dehydrations are there. these are the terms which are interchangeably used by people, but there is a difference between the both. For an example, in case of the drying, we refer for the removal of the water to an EMF or EMC is achieved, that we say as equilibrium moisture content. Then dehydration majorly is being referred in case of food application, where we remove the water to a bone dry condition. But removing the water to bone dry condition, especially in case of the food, is not desirable, because it eventually will deteriorate the quality or organic component of the food. That is why it is preferred to go for the different drying technology to remove the moisture content, that we refer as thermal drying. Now, the question is why we need to use the processing thermal drying, for what is the need? The very first thing is, through the drying we can reduce the post harvest losses, as we can see during the supply and chain management, or even after just harvesting of the grains, we need to dry them and put up them. During that interval, because of the insects, because of the many aspects, the post harvest losses occur. In order to ensure food security, we need to go for the processing and preservation through drying. Surplus availability of raw material in peak season. Suppose you might have heard that there was time when tomato or potato, when are in excess production, instead of selling them, people used to throw them on the roads, because they are excessively available and the transportation cost is more, and the amount or remuneration being received for the selling of is very less. But at that time, for considering the future aspect, we need to secure the food for the future generation, or for the future time, or during the emergency situation. We need to preserve them in different forms, which can be dried powder, which can be dried slices, and in various forms through the drying. Again, we know that most of the fruits and vegetables, they have a moisture content ranging more than 70% up to 90%. Due to presence of this high amount of the moisture and high water activity, the food is basically deteriorated easily by the different kind of the microorganism. In order to prevent the growth of these microorganisms, we need to dry them or preserve them for different application. Again, non-availability of the commodities throughout the country. For an example, if mango is popular into the central India, but we need to supply it to the north also, to the south also, to make it available throughout the country, not restricting it to the area where it is grown. So, we need to preserve, because most of the fruits and vegetables, they have a very limited shelf life. Okay. So, to transport them, we need to process them or preserve them in some form, so that they can be transported easily. Obviously, since we are reducing the moisture over here, so that is why the bulk volume is being reduced, eventually reducing the transportation cost. And obviously, if you have reduced the moisture, it is easy to handle during the processing aspects also. Now, if we can see the losses where it is occurring, in which area it is more, we can see that in the agricultural production around 15% losses are happening. 9% are happening at the post harvest handling and storage, 25% are happening at processing and packaging line, 10% are happening at the distribution channel, and at consumption level also, or at consumer level also 7% are happening, which could be because of the expiry of the product, or because of the microbial growth, or not properly storing, can lead to the losses at the consumer ends also. So, that is why if we can go for the drying technology, which is very an essential operation, if we store them properly and dry them properly, these spoilages that we can see in the picture, they can be reduced. Like you can see lot of the mold spoilages in the peanuts, and then in the case of the corn and the other walnuts and different kind of the product. So, this, and apart from this one, it is not about the spoilage, it is about the safety aspects also. These mycotoxins can affect to the health of the human being, and that is why in order to reduce these growth, we need to dry them, we need to preserve them, so that can be available throughout the country or can be utilized during the time of the need. So, how we can improve this food security and safety aspect while reducing the losses is through drying of the different commodities or different sectors product. For an example, among cereals, legumes, if we store them at proper temperature after reducing the moisture content through the drying is one way. Drying of fruits and vegetable, converting them into the powder or into the slices or into the cube form, where they can be used as a natural snacks item also, then we can reduce these losses and improve the food security. Meat and marine product also have very limited shelf life, again are very prone to spoilage. If we can mince them and powder them or paste them and preserve them, can save in several aspects. Drying of insects, these are very getting a lot of attention from the manufacturers, from the consumer ends, and especially in foreign countries, because of the presence of high amount of the protein content into it. Despite we are the producers of these pulses, and still we have to procure these pulses from the outside. In order to compensate those things, we need to look up for the alternative protein sources also, and insects have very high amount of the protein into them. So, drying them and converting into the powder and supplementing the food product can be one of the way. Now, how we can manage these food wastage? These food wastage, we can dry them, whichever the byproducts are being generated, to reduce them as manure. Food waste may be dried to produce as a biofuel sources. They can be used as a fermentation media, since byproducts especially from agricultural commodities are good source of the carbon and nitrogen. So, they can be supplemented as a natural media, and if we reduce the moisture content, they can have been stored for a longer time. Feed meals to the animals, these byproducts, since as I was mentioning, if you take any kind of oil seed, if you can take any kind of okra of any pulses or the legumes, they are very rich source of the protein. So, drying them, reducing the anti-nutritional factors, we can use them as a animal feed, okay, which could be a good source of the protein and will increase their growth rate for the animals. Now, since we talked about what are the losses happening, what are the changes happening, so there is a need for securing the food, there is a need for the looking about the safety and the quality aspects. And there are many preservation technique, and among the, let us say, from different preservation technique, we have chosen drying. Now, again, after choosing this is also not easy. Which type of drying? There are thousands of the dryers available into the market. If you search on the internet, which type of the dryer is economical or you want to use, so which you will choose. So, there is a lot of confusions about the type of the drying technology. So, we have to look up or come up with the plan or the strategy to select the type of the drying technology, or you can say as the type of the dryer to be used. Like we have sun drying, we have tray drying, we have vacuum drying, freeze drying, superheated steam drying, spray drying, fluidized bed drying, drum drying and microwave drying. What to choose is very important, since it is not a lab scale experiment, it is you are investing something, and these dryers are not cheap, they come up with a cost, and this is not the one time cost, it is again the operating cost also. In drying, the operating cost is very important, because lot of the energy is being consumed during the processing aspects. That is why calculation and considering the fact of the operating cost is also very important over here. So, how we select the dryer? Like for an example, before selecting the dryer, you need to know that what is the product size final output you require, either in microns to centimeters. What is the porosity that you require in your product? What is your desirable output quality of your product? Knowing that is also very important. The time it take to dry, like for the leaf, it take very less time, 1 hour to 3 to 4 days for the drying of the wood sample. What is the production capacity? Do you want in a batch scale? Do you want continuous one? What is your desirable or production capacity of your house is there or industry? The product speed, the conveyor belt moving speed, that is also very important. Time for the drying is important. The temperature, like either you want to go for under vacuum drying or under freeze drying or at atmospheric condition. These are very important to decide. If for an example you are dealing with a pharma kind of the product, there you need to have a very important aspect is the quality of the this one, or microbial drying or strain drying, or that there the freeze drying is very important, and you need to go for under vacuum drying. Then you have continuous or intermittent drying, because these are the ways to save the energy or the operating cost of the dryer. Then mode of the heat, conduction, convection, radiation, microwave, radio frequency, or in combination, how you want to go for this one. Medium of applying heat is also becoming very popular, like normally it is the hot air being used, but different kind of the flue gases can also be used, and superheated steam is becoming very popular nowadays in terms of the research community and getting the attention from the industries also. What is your phase of material? Do you want the output product solid, semi-solid or concentrated? You have to, these characteristics of the product help you in deciding type of technology or type of the dryer also. For an example, let us make it little easier for you to understand. Here we see, let us say if your food or your product commodity is liquid material, then it is preferable to go with the drum drying or spray drying. Like for the milk, it is very popular to go with spray drying or drum drying. For fruit juices, along with addition of some high molecular weight compound, spray drying is also very popular there, and based upon the solubility you want into the product. For particulate material, it is good to go with rotary type of the dryer, and fluidized bed dryer is also very popular. For an example, you would have seen in case of the pea or small particulate material, it is very popular, and the drying time is also less over here. For sheeting the material, like microwave and infrareds are popular. Then again for pasty kind of the material, you can go with the spray drying, drum drying or pedal type of the drying. Starting from the basics, that is sun drying and is oldest preservation method. Over here, in case of the sun drying, you can see over here the very simplest method is the mat drying. As from the figure also, you can see over here that we place the net or mat or plastic sheet, and where we spread our material over this net or the mats. The advantage is that less contamination with stones and other dirt is possible since you are using the mat. It is easy collection in case of sudden rainfall is there, and easy mixing is also there. What could be the disadvantage then? Disadvantage is the danger of re-wetting of the bottom grain from the soil moisture, which is a problem and troublesome thing. Alternative is pavement drying. If we have a bulk of the produce, and it is better for the farmers, grain collector and traders and millers to use the pavement drying, because the material being handled is in the bulk amount, okay, and in tons. So, specially constructed for the drying purposes, and these are multi-purposes, can be used for other aspects also. So, the advantages of the technology include high capacity, economics of the scale is there, can be partially mechanized by some motor or rotor movement, so that can be grain can be rotated. Tools for mixing and grain collections, larger mills often used for these one. But what are the disadvantages associated? Capital requirement for the pavement, possibility of rodent and bird insect invasion is there, difficult to collect during the sudden rainfall, again can add moisture to the product and add to the economics of the cost. These are the some of the disadvantages. Here you can see how we go for drying of the fruits in sun, drying of vegetable, hanging it, the meat, so that maximum surface area can be exposed, so that drying could be faster. But several limitations are there, as the drying time is very high, especially for the fruits where the sugar content is very high. Again, some pollutions, insects and these birds, animals, they can contaminate the food sample. Again, you have to use alternate heating, because in the day sometimes it is not possible to dry. So, overnight you have to keep, and during that time of the night thermal stress or crack can happen, or again spoilage from the microbial growth can happen, which can eventually deteriorate the quality of the produce. Now, right now it is not only the safety, the quality also is very important over here. Again, it has to be dependent on sunshine, like during winter seasons, especially in hilly areas or north areas where of India, especially where the winter season sun is seen very less. So, there are uncertainty attached through the sun drying technology. Again, drying area required is very large. Though some of it can also be overcome by some ways, like we can increase or layer depth up to 4 centimeter, mixing the grains every 30 minutes, though it will add to the labor cost, monitoring the moisture content, monitoring the temperature. For other protection that can be given is like covering the grain when the temperature is more than 50 to 60 degrees Celsius, covering during the rainy season, using of some mat, inspection, preventing the waste whatever can lead to the contamination, keeping the animals and the birds off the grains. As you can see from the picture also, here how we can reduce these through the tips, we can improve the sun drying technology. Coming to the next technology, that is tray drying. As we can see from the figure, here we can see the tray drying dryer, and here is the mode of the operations. Basically, in this one we involves a drying chamber, air distribution system, or media can be anything. It can be air, it can be steam. Majorly in tray dryer, it is the air which is being used as a medium. The fan, the air heater, if you are using air, we need to heat it so that it can take up the moisture from the sample. Some conveyor belt, if it is a continuous system. In the batch system, we do not require conveyors. Accessories like measuring the moisture meter, dust separator from these one that can be used. How it happens is, basically these trays are there that you can see over here. They hold the product inside the cabinet, okay, and they are exposed, the samples being kept over these trays are exposed to heated air at high velocities to ensure that heat and mass transfer, both are very important, heat and mass transfer occur, leading to reduce in the water activity of the samples. This is how the tray drying work. Now, since if we talk about technology, there are some advantages and disadvantages associated with the technology. What are the advantages associated over here? It is very simple in handling, lesser capital cost is there. What are the disadvantages associated? Sometime you would have seen that non-uniform drying of the product occur. Drying time is very high and labor cost is also high over here due to loading, unloading of the drying material. Again, some burning of the, because of non-uniform heating or the product quality is not that good. Especially for the heat sensitive material, it is not a very not preferred type of a technology, because there is a loss of the heat sensitive compounds like your beta carotene, your vitamin C. So, the product rich in these components are not suggested to go for the tray drying. It is majorly used for grains or other kind of the agricultural produce item. Followed by is the another technology, that is the vacuum drying. As the name is indicating, in this type of the technology, we try to use a vacuum oven which consisted of a jacketed vessel to withstand the vacuum within the oven. Okay. The function of the vacuum over here is to suck up the excess air based upon the pressure being used to operate, okay, and which eventually can reduce the boiling point of the water. So, reducing the boiling point means we are drying at a lower temperature, at low temperature conditions, which is very much suitable for heat sensitive products, especially fruits and vegetables. Okay. So, the oven is connected to a condenser and liquid receiver to a vacuum pump, and we can dry at a very low temperature also, especially for the drying of the microbial culture also, like we have several vacuum dried or freeze dried culture that can be used. Talking about the component of the dryer that are there into this one is the drying chamber, where we need to keep our sample and need to dry the material, tray where we keep sample, heating element, vacuum pump to remove excess air and reducing it to negligible amount, but will depends upon the pressure operated over here, fan and other monitoring devices. So, advantages associated is that drying take place at a very low temperature. So, that is a good aspect over here. Maximum retention of the nutrients are there, especially heat sensitive compounds, and since little air is present, so the minimum risk of oxidation is there. Browning is very less is there in case of vacuum drying. Additional cost due to vacuum pump is there, so the operating cost become more, that is the disadvantages associated. But the suitable applications are heat sensitive commodities. Okay. Here you can see vacuum dried and hot air dried sample. This is the vacuum dried oyster and mushroom, and this is hot air drying. A difference in the color can be clearly seen. Similarly, vacuum dried beans and hot air dried beans, the temperature, or forget about the temperature, here from the picture itself we can see at similar operating condition a significant difference in the color can occur. Again, onion, it can be red, it can be white. A clear difference in vacuum dried and hot air dried products can be seen. The other ways how we can monitor these color is by measuring the LAB value and calculating the total colors change of the sample can be done, and which can eventually give you idea about the quality aspects of the product. Going further, very popular freeze drying and but costly technique is there, as the operating cost of this technology is high, but the quality is very premium quality of the product is obtained through these drying technology, especially any kind of the pharmaceutical product, fruits and vegetables or probiotic based product. These are very popularly dried by these technologies. So, freeze drying is the, as it indicates, first before going for the drying operation, we need to freeze the sample. So, the process in which water is frozen followed by the removal of the moisture from the sample, initially by the sublimation, where directly from the frozen state the moisture is being evaporated without passing through the liquid stage is known as sublimation. And after this sublimation, the secondary drying occur by the desorption method. So, the process involves freezing of the food, so that water in the food becomes ice or solidified, and under a vacuum sublimating the ice directly into the water vapor, drawing off the water vapor, and once the ice is sublimated, food or freeze dried and can be removed from the dryer. Okay. Again, the chamber or the setup involves a drying chamber, a trace, vacuum pump to maintain very low pressure, condenser to collect the excess moisture, and other monitoring devices. This is a commercial freeze dryer that are there, and they are handling in the bulk amount of the material, and long capacity type of the dryers are being used into the industry. Since consumers are becoming very health conscious, so they are using these freeze dryer product because the quality retention is very high, and we do not need to use some preservatives like salt or sugar for various fruits and vegetable product. Rather, we get the product without using these kind of the additives, and a very good quality compounds or are also retained during the processing. So, advantage is that drying takes place at low temperature, product is light and porous. The porous form of the product gives ready solubility, which is also of very important, especially freeze dried powders, fruits which are in very demand nowadays. Concentration of solution prior to drying, nutrient retention, there is little air present. So, there is minimum risk of oxidation is there. The brown color that is very commonly seen, especially in some product which can on exposure to the air can easily be oxidation happen. The another limitation for the, or that you can say what are the disadvantage associated are the porosity and ready solubility, and complete dryness also leads to the product of a hygroscopic nature, which become the troublesome sometimes depending upon the type of the product. Another is process is very slow, that is also there, but it is being very commonly and fondly being used for biological products like antibiotics, vaccines, enzymes and microbial culture, and becoming very popular again in case of the food industry also. This is the phase diagram of the water, how the three drying technique that we studied, hot air, vacuum and freeze drying, they can also be depicted into this diagram. Like at higher temperature side, it is the hot air drying that majorly occur. This is the triple point of the water. The vacuum drying occur above the triple point of the water, and freeze drying occur below the triple point of the water, and at low pressure and at low temperature condition is there. So, freeze drying takes place below the triple point and vacuum drying takes place above the triple point of the water. Coming to the important or innovative technology that we will discuss is the superheated steam. So, you will get a fair idea about the drying technologies. Here talking about this superheated steam. So, what is that steam? What is superheated steam? That is important. So, steam that has been heated beyond its boiling point, but boiling point at what pressure is also very important, that is above the saturation temperature. If we say, then we say it as a superheated steam. Okay. Like for an example, at atmospheric pressure, the water boils at 100 degrees Celsius. So, steam is being formed at 100 degrees Celsius, that is totally saturated. So, if we heat it beyond 100 degrees Celsius, further addition of the heat to the saturated steam will make it superheated steam. Like you have water supply, we heat it into the boiler, steam is being generated, and over here if we add another heating element, then this capacity of the steam increases and have higher thermal or heat transfer capacity, and we can use it as a medium for the drying. Here are the product, and where we have kept over the trays, it has so much thermal capacity or heat transfer capacity that it can take the moisture from the sample and dry the product. Superheated steam drying is very useful since high heat transfer rates are there into the technology. High thermal conductivity of superheated steam is there, and less energy consumption is there if we operate it into a closed circuit, that we will see into the next diagram as well. The principle of operation or the drying rates, it depends upon the heat transfer rate. Since there is no resistance to diffusion in its own vapor, because steam is in form of vapor, and here there is no resistance, like if vapors are being generated, if it is air is there, then air will provide the resistance to the vapor. Since in case of superheated steam, these are vapors only there, so resistance is less, so drying rates are higher. The mechanism remains the same, the difference lies is only in the T surface that we are using. Okay. In case of the superheated steam, it is the steam saturation temperature. In case of hot air, it is the wet bulb temperature of the air is there, where N is the evaporation rate, where Q is the heat transfer rate, H is the convective heat transfer coefficient, and lambda is the latent heat of vaporization. Okay. This is how we operate if superheated steam into a closed circuit and use it for the different operation. Lot of the energy can be saved, like for an example as we talked about. In a steam generator, the steam is being generated and then it is being passed through a further heating element to make it superheated steam, then it passed through the drying chamber. Okay. But the temperature is still, some condensation can occur, some decline in temperature is there, but it is always higher than the normal temperature condition. So, over here once we circulate it, we can save energy. Secondly, since it has taken some moisture from the sample, that energy can also be recovered from over here through the exchanger, and we can condensate the material also, and some of the volatile compounds that might have gone along with the superheated steam can be collected and recollected and can be used for the application. So, saving lot of the energy aspect into this one. Coming to the very important, that is, we should always ask a question, why this technology, why it is important. Okay. Talking about the product benefit. As the superheated steams evolves out from the product, increases the product porosity, leading to the better product quality if the porosity is of very importance. Again, since oxygen is not there, we are using superheated steam as a medium over here, therefore, restricting the oxidation and followed by the changes which could be led by the oxidation process. Again, energy efficient. The first thing that we talked into a closed circuit is that we can save lot of energy. Again, even we can utilize the exhausted heat and collect the condensate also. Collecting the condensate will help in solving the environmental issues, like sometime there are toxic compounds that are being released into the environment directly. Here we can condensate it and dispose accordingly, thereby limiting the environmental issues. We can operate this superheated steam at 3 pressure condition. One is very popular, is at atmospheric condition, then at high pressure condition, and then at low pressure condition. In case of atmospheric condition, like most of the meal or left out byproducts, we use that atmospheric condition. Similar kind of the product can also be drying at high pressure, but high drying rates can be there. That is the aspect. But if your product is heat sensitive, then we go for the low pressure. So, combining vacuum with the superheated steam will give it as a, or can be said as, low pressure superheated steam drying technology. Talking about the first mode, that is high pressure. The high pressure, it can be drying for the product of like beet pulp, operate at a pressure like atmospheric pressure is around 1 bar. So, we can operate around 5 bar, consumes 50% less energy than conventional air dryer. Product quality is better in terms of texture and appearance, and several pilot scale type of the dryers are there for drying of fish products or pulp or some of the spent grain from the brewery, so that we can have them further application. Talking about the atmospheric pressure, the product that has been dried through the literature is available into the SCI or over the different platforms, that potato chips have been dried, tortilla chips have been dried, soybean, noodles, these have been dried at atmospheric pressure using superheated steam, and better product quality has been obtained in many cases than air drying. And comparable drying rates has also been achieved. This is one of the setup of a superheated steam dryer, where we can use hot air also as a medium and superheated steam also as a medium in a same dryer, only by operating by through the different walls that can be achieved. If we can see that these are the drying rates that can be achieved through the superheated steam and hot air drying of the potato slices. The only thing that we need to take care in case of superheated steam is there some initial condensation is there. So, some additional moisture is there. So, little longer time can be taken, but if we are operating at higher temperature, comparable results in the drying rate has been obtained, and the product quality has also been found of good thing. So, the first we talked about the high pressure, second I talked about the atmospheric superheated steam, third is low pressure superheated steam dryer is there. This is the setup that is available in KMUTT Thailand University. These are some of the literature that have used superheated steam drying at low pressure for drying of mangosteen rind. It is one of the very popular fruit of this one, and is also known as queen of the these fruits. It is a very good source for the xanthones, and during this one of the studies by Swarn Kota, which was published in Food Chemistry Journal, which is of very good high impact, they dried the mangosteen rind, like we can see in the figure also, these rinds are there at low pressure condition at 60 degrees Celsius, 75 degrees Celsius, at 90 degrees Celsius, at pressure maintaining one condition 7 kilopascal. And this drying method significantly degraded these xanthones and antioxidant activity, but low pressure superheated steam drying at 75 degrees Celsius was found to be more appropriate drying technique to preserve the xanthones in mangosteen rind. These are the different drying rates that have been achieved at different conditions of these temperature. And next is the Indian gooseberry, and we say it popularly as amla. Okay. It was also dried at 65 and 75 degrees Celsius at vacuum drying and low pressure superheated steam drying LPSSD, but varying the pressure also from 7 to 13 kilopascal. It was found that vitamin C retention was very high than the vacuum drying. Okay. We can see over here vacuum drying was done, low pressure superheated steam drying done, temperature 65 and 75 at 3 pressure. Okay. We can see at low pressure at 65 degrees Celsius and 7 kilopascal, and at all the 3 pressure condition at 75 degrees Celsius, the vitamin retention was quite very high comparative to the vacuum dried samples. Another example was of the carrot. As we know, carrot is also a rich source of beta carotene. So, the drying was again done at from 60, 70 and 80 at 7 kilopascal, and very good retention was obtained at 60 degrees Celsius at 7 kilopascal, and this results were also published into the Food Chemistry Journal by the various authors from the different countries. These are the drying rates that were obtained. This is the review that I published during my PhD work, and we found that superheated steam is making a lot many progress from the previous time and getting a lot of the researcher and industrial attention. And through this review article, majorly we highlighted that superheated steam is a novel technology with product, energy and environmental benefits. Knowing the mechanism and kinetic modeling of the process is very important, and kinetic data may be used for effective designing of the process, as commodities will vary based upon the component retention into this one and the commercial aspect of the commodity. So, we also design a similar dryer in my PhD work, and this is the type of the dryer we design. We can perform hot air drying and low pressure super one setup only. Okay. Comparison become easy as we are for drying the same type of the system, just varying, changing the mode of the heat only. Different channels on the flow walls or the walls that were attached over here, like you have temperature, you have pressure gauges and these coils, and through which hot air drying mode, vacuum drying mode, superheated steam drying mode of these. Several products were dried using these one in both these mode. They can also be the outcomes or geometry specific shortcoming can be removed using same type of the dryer, and it is more effective and faster way to compare to a commercially import alternative also. The work that we did in this setup in detail, over here I will show you majorly results for the onion. Some of the pictures. Why we chose onion? Actually, India ranks second, very good source of thisulfonate compound, the pungent compound that give terry and flavonoid rich, and these presence of these component make and antibacterial properties. Apart from that, after we have onion, these can have several application like spices, can be used for gravies and other food item. Onion, after rehydration we can use them and as a, since we dried using low pressure superheated drying, hot air drying and at 3 temperature, we found that the quality retention was superheated steam drying at 70 degrees Celsius. In case of the LAB values were lower for the, can be seen from the browning index and total color, lesser for this one, and lesser the browning, lesser the is more preserved through the processing. Rehydration for low pressure superheated steam dried at 70 was comparable for vacuum drying at 60 for 80 also, and for 70 and 80 showed similar result, but the hot air dried sample at 60, 70 and 80 degree. Thisulfonate retention for the low pressure superheated steam dried at 70 degrees Celsius. The results were comparable for the hot air dried one, and continuous degree to 70 to 80 degree Celsius. Total phenol compound, these flavors and gave a good impact on or metabolism or boosting the immune system. Differences were that at hot air drying at 60 could be seen, but results were comparable steam drying at 60, 70 and 80 and 70. These are the volatile. Say if we are having any heat through the GCMS analysis, we can presence of the volatile compound literature. Through these references, we found that these are the retained compounds that were obtained like sulfoxide, butyric acid, 2,4-diphane, and all these compounds were in the onions. Then we them that what are the compounds in respect to the fresh onion. The thiopropanol sulfoxide compound was not detected in any of, but in hot air drying techniques many compounds detected. It indicates that during the hot air drying, these moved as a these were and were degraded during the drying technique. The retention was quite high compared to low pressure superheated steam drying at 7 Celsius. These are the scanning electron micro pressure superheated steam dried, vacuum dried and hot air. We can clearly see in case of 70 degree and 80 pores are open, uniform and bitter, or broken or degraded structure can be seen in hot air drying at 60 is still okay, and vacuum and 60 are fine, but at 70 degrees Celsius a degradation can be seen. Like that was the example or a comparative study that we did for these were also, these are hot air dried, these dried and these are low pressure, more puffing, less can be seen in case of low pressure dried samples. The burning and these effects can be seen in case of samples. So, this work was published for the in case of the onion slices in Journal of Food Science and Technology, and for mango also we published in the LWT journal, and these studies highlighted that these onions and the mango dried using these one have a very good prospect in the future in term of the quality retention of these commodities. Apart from that, here also we can see that the energy consumption for different drying processes is given over here, and this energy consumption is kg per kg of water being evaporated. We can see that for the freeze drying a very high amount of energy, that is more than 6,000 kilojoule per kg of water is required, whereas in case of hot air drying it is around 4,000 to 6,001. For superheated steam it is only 1,000 to 1,500, which is less, but this is it if you operate it into a closed circuit, then only you will be able to achieve this one. So, we have lot many opportunities with different sciences also, like we can design this multi-purpose dryer with more of using infrared heating medium also, or some shaking or ultrasonication to enhance the drying rates. some chemical and structural microbiological changes at a molecular level, energy calculation with the mechanical people, modeling and simulation that can be achieved to have more efficiency of the process. To conclude, I would like to say drying could be one of the solution of the problem for reducing post harvest losses, as well as will be helpful in reducing the impact of the food wastage on the environment. Considering the strong relationship between drying and national food security and health of the people, it is important to enhance the drying research and development. A multi-purpose dryer can be one of the aspects, so that the comparison for the research and for the industrial application can be there, and the target should be to retain the quality, because safety we have achieved already by many ways, but quality is also very important to reduce these losses and for consumption of the human being. These are the work related to the low pressure superheated steam drying or to the drying that we have done in LWT, Innovative Food Science and Technology, Journal of Food Science and Technology, Journal of Agriculture and Engineering, and 2-3 book chapter that we have published related to this one. These are the references we take while preparing these slides. Thank you everyone. If you have any questions, please feel free to ask.